Okay, everyone, we welcome you to this section 1 that is about image classification with machine learning. To go through this section 1, we assume you have Python basics and a data analysis with Python. If not, check the prerequisite from workshop video or our paper and the supporting information to learn the Python basics and the data analysis with Python. If yes, let's continue. We will introduce you image classification with machine learning. In this example Colab notebook, we will introduce the basic convolutional neural network model and classify fashion amnest dataset, which contains 28 times 28 grayscale images of 10 fashion categories. From this notebook, you will understand the basic workflow to train and evaluate a model, and use the model to predict close categories, or we call this process inference. And this is the table of content. This actually shows the basic workflow to train and evaluate the model. So first, we'll load images dataset, and then prepare the data for build and train the model, and then evaluate the model performance. Finally, run the inference on test dataset or some new data. So you can click the table of content button in the left side, and it will show the table of content. You can click any section you want to go. Okay, and let's go back to our beginning. Let's start the first section, load images dataset. So at the beginning, we will directly load the fashion amnest dataset from Keras. Fashion amnest is a popular dataset that is used for image classification. More details about this dataset can be found on this website. So we click it. So you will see that this shows the detailed information for the fashion amnest dataset. Actually, this website is the Keras documentation, and this located in Keras API reference and a built-in small dataset. To load the dataset, we can run the code in here. You can just copy and paste this code into our notebook and run it. You will get the fashion amnest dataset, and you can see it contains all of the classes and the labels and the descriptions of it, and also you know what these functions returns, like that. And in this documentation, it also gives us an example to show how to use this code. So go back to our Colab. Our code for loading amnest dataset is the same with the Keras documentation. So in order to run this code, you can just click this button. So actually, for all of our example and a solution notebook, it contains the code in this block, also the output. You can click this start again to generate the output with the same way. For this is just let us import the packages. So it's just the basics of the Python. If you don't know the basics, just remember, go back to check the prerequisite. Okay, and then after finishing this, we load the fashion amnest dataset in our Colab notebook, and then we will prepare our data. So this block of the code showed us to visualize the dataset. It just let us to say what the dataset look like. You can click it. It will run in the game and show nearly the same results. So this shows how the fashion amnest dataset look like, just from the Xtrain4 dataset. Okay, and then we will prepare our data First, you split the X-train fault into X-train and a valid dataset. So by running this code, you will assign 5,000 images in the X-train fault as a validation dataset. The rest of the images will be the training dataset. So if you don't understand what this code means, so go back to check the Python basics. And you have normalized the dataset. This just let us have a stable and a better model performance. Okay, and then let's start build and train the model. So the simple CNN is used to train the model. It is usually composed of different layers in Keras, as I mentioned in our workshop PPT. So the layers are the basic building blocks of a neural network. So those layers are composed of and can be referred in Keras documentation. So if we want to use the convolutional layers, you can just click it. So this again is the Keras documentation. This shows us some details about a convolutional layer and how to use it. So if you want to learn new things, it's better to find out the root knowledge. So if you want to learn Keras, this documentation is one learning resources we cannot avoid. And again, it also provided some examples, tell us the details how to use this convolutional layer. So go back to our code. Again, for the pooling layer and the input and dense layers and the flatten layer, all of these are the Keras documentations. And then you will use all of these layers to compose a structure. This is the CNN structure. So the structure, one example, can also find out in the Keras documentation. And you can also find some structures in related books, like this one, Hands-on Machine Learning with Skitlearn, Keras, and TensorFlow. We also provide some great books in our paper and supporting information. So let's look at our code block. So this is the syntax of the Keras. You will use it to build up your model. So you will see that this convolutional layer and a max pooling layer and so on. So you click it, you will build the model. And then we will compile our model by giving it a loss optimizer and a matrix function. So the purpose of loss function is to compute the quantity that a model should seek to minimize during training. So we can click the documentation, still the Keras documentation, to find out the detail of the loss functions. Actually, there's a lot of loss functions we can use. So in our case, we use the sparse categorical cross entropy functions. You can click it to read details about it. And again, the same thing for the optimizer function. There's a lot of optimizer functions we can assign to our model. The same thing for the matrix. And then by running the code like this line, model.fit, and we will start to train our model. Let's start it. And the training process of the model will take a little bit of time, and after it finishes, we will go back to say more. Okay, after this training process, finally, you will get a trained model. So you can use the trained model to evaluate the performance of it and also run inference. And at first, we can visualize the model structure by running model.summary. You can comment out this code and just click the start button. We will see the model structure and also the parameters of it. The test dataset is not used for training and validation, which means the images are new to train a model, so we will use it to get the performance of the model. You click it, you will see that Colab will calculate the loss and accuracy for the trained model. So if you see the accuracy in here and also the training dataset accuracy and validation dataset accuracy, you will see that the accuracy of those three datasets are nearly the same, which is a good sign. So, and at the end of the epoch, the accuracy of training dataset and validation dataset should be close. This is an easy way to determine if there's overfitting or not. So you click it, we will get the figure like this. You will see that at the end of the epoch, the training dataset and the validation dataset accuracy are nearly the same. Okay, we can run the inference using the trained models. So this code is to let us choose the image we want to run inference and then show this image. In here, we choose the number 1. Actually, you can choose any number in this range. And then you click it. It will show the image. We can use our judgment to see what piece of clothes it is, and then compare to the model prediction. And then let's see what the model predict. So this block of code is just let the model make the prediction. So the main line of code is in here, model.predict. So this is to make the model predict. So if you want to learn more about this line, so you can click this link in here. It's the Keras documentation to talk about more of the model.predict. And then let's run it. You will see that it generates probability for each of the category, and the close of the category the model predict is a pullover. It's the same with our judgment. And of course, we can choose another image. You can change any numbers in this range because we have a test data set about 10,000. Okay, you run it. Here is another image. So you make the model predict. It's trouser. Okay, here is the inference.